Hey guys, in this video, I will show you how to use this SQL strategy to construct a SQL select statement that involves group by. So this strategy is very useful when you encounter a problem that you expect to use a complex SQL query like this to tackle with. So to demonstrate the usage of this strategy, the data context I'm using will be two tables. The first table being the student table that has 6 students, starting with the student ID, first name, their last names, ages, and their GPAs. The second table being the assignment table, which has 6 columns: assignment ID, assignment names, the student ID, who submitted these assignments, and the assignment scores the students received for the corresponding assignments, the due date for each assignment, and the actual submission time for each assignment. So in the assignment table, there are in total 72 rows, or 72 assignment submissions made by the 6 students. Okay, and to prepare these two tables, if you have followed my previous lessons, you should already have these two tables in your EC2 database. But just in case you don't, you can find the script from this lesson module. So what you need to do is to copy the whole script that I prepared in this course module. Okay, up to here. So please copy the whole thing and paste it into the new query window in your SSMS. Okay, just like this. Okay, you can paste the whole script here and press this execute button, which will create two tables and also insert the 6 plus 72 rows in those two tables. Alright, so in order to demonstrate the usage of this strategy, I will show you two examples. So the first example is to show students their assignment statistics, which means the number of graded assignment submissions for each student. Also calculate the average assignment scores, the lowest assignment scores, the minimum, and the highest maximum assignment scores for those assignment submissions. But only shows results for those whose average assignment score is higher than 80. Okay, so as you can see from here, the expected result is the list of students, their number of graded submissions, and their corresponding average, lowest, and highest scores. Okay, and this is the standard answer for this SQL query, which has 5, 6, 7, 10 lines of codes. Okay, so in this video, what I want to show you is how you can generate or construct such SQL query that involves group by. Okay, how we can use this strategy to easily come up with the 10-line code that I just showed you. Okay, so let's get started. The first step in this strategy is to select everything. Okay, select star from all the relevant tables. Okay, so we will start from here. So now, what is the all relevant tables? So in this problem, you need to select star from the two tables in this context. Okay, we need both student and assignment tables. Okay, because obviously we need students' names in the student table, and assignment statistics can only be calculated based on the assignment table. So we need to select star from the two tables, both of them. Okay. So in the next step, we need to work on joins. Okay. So when we are selecting data from multiple tables, we need to properly work on joining them. So in this case, we have a student table whose primary key is student ID, as you can see. And in the assignment table, we also have a foreign key column, student ID, that refers to the student ID in the student table. Okay, so we need to translate this fact in the SQL query. Okay, so come back to here. Select star from student assignment where student ID in the student table. Okay, so we can use the dot reference to represent the student ID column in the student table, where student ID in the student table equals to assignment table's student ID. Okay, so we are basically just using an equal symbol to say these two columns coming from different tables, they refer to the same thing. Okay, so these two steps, okay, it's always a good habit to run the query in the middle to take a look at the intermediary results, just like this. Okay. And of course, this is far from our expectation, students and their assignment statistics. So let's move on to the next step. Our third step is narrow down the rows by applying appropriate conditions using the where clause. Okay. Narrow down the rows by applying appropriate conditions using the where clause. Okay, so what does it mean? It means the currently returned results here are far from our expectation. Okay. In other words, it has too many unnecessary information, or say unnecessary rows that we don't want to include in the final result. Okay. So let's tease out those unnecessary rows one by one. Right. So first of all, take a look at this problem statement. Okay. We want students' names, their assignment statistics that include the number of graded submissions. Okay, so in order to check which assignment submission is graded, which is not, okay, we need to take a look at the sum columns here. Okay, assignment score. Okay, so we realize that some assignment scores have null values. Okay, for example, Jack Gray has submitted an assignment. Okay, so it seems that he didn't submit the assignment because the submission time is null. Okay, assignment score is accordingly null. But for row number 6, there is a submission time for Ellen White's assignment submission, but she didn't receive an assignment score. Okay, so we need to tease out all the ungraded assignment submissions by looking at the assignment score column. Okay, so this can be translated into the SQL query by saying assignment score is not null. Okay, we only want to keep the records whose assignment score is not null, because not null represents those assignment submissions have been graded. Okay, and we want to show the number of graded submissions. Okay, we want to count the number of graded submissions. Okay, in other words, we don't want to count in the number of ungraded assignment submissions like row number 6. Okay, so that's where we use the where clause to tease out some unwanted rows from the results. Okay, so because we are using the where clause in the previous line, we use the and keyword to add this additional filter. Okay, so let's move on to the next step. The next step is identify the columns. Okay, one column or multiple columns. based on which we perform a group by statement. Okay? And further, we select such column or columns. Okay? So what does it mean? So it means we need to determine based on which group, which column we perform group by. Okay? So in order to decide that, it's a good idea to imagine what will be the final results that we expect. Okay. So in this case, we are expecting students, their assignment statistics. Okay. So it seems like we want a list of student names to begin with. Okay. Student names to begin with, followed by their aggregated assignment statistics. Okay. So instead of age GPA, we want like average score, the number of graded submissions, the minimum, maximum, okay, things like that. Okay. So we want our final results to start with students' names, including their first name and last names. Okay. So that means these two columns are the columns based on which we perform group by. Okay, so as you can see, it's okay to group by multiple columns like this. Okay. Right. So a common mistake is, as you can see here, when you execute this partial code, it will give you an error, invalid column first name. Okay. So, but even I change the typo here, I fix the typo here, it still gives you an error message saying the column is invalid in the select list. Okay. So this kind of error can be easily avoided by this tip. Okay. Whatever you group by, copy it. Then replace the star with the copied column or columns. Okay. Once again, let me repeat it. Whatever you group by, in this case, first name and last name, copy it and replace the star asterisk with it. Okay, so now my SQL query reads like select first name, last name instead of everything from the two tables. So let's run it. Okay, so this tip will help you avoid the error that I just encountered. Okay. Once again, whatever you group by, use it after select. Okay, so this will eliminate this type of error entirely. Alright, so let's take a look at the current partial results. Now we have a list of students. Okay, but of course we don't just want their names. We want their assignment statistics, including these four. Okay, so it's time to move on to the next step. Expand the selection by adding aggregate functions. Expand the selection by adding the aggregate functions. So what does this mean? Okay. So this means we want to expand from the current partial results to the right, okay, by adding those aggregated numbers that we are expecting. For example, the number of graded submissions. Okay, we want the number of graded submissions for each student to show up here. Okay, so similarly, we also want the average assignment scores for each student to show up here. The lowest score for each student, highest score for each student to show up in their corresponding row. Okay, so that means we need to add the aggregate functions after the thing we select here. Okay, so for example, now the number of graded submission can be calculated by count function. Okay, the aggregate function count. Okay, count star, for example. Okay, so let's run the partial results now. Okay, so now, as you can see, the partial results show a list of numbers that represents the number of graded submissions. Okay, so they are graded submissions because we have added this filter here. assignment score is not null. Okay, count star now is counting the number of records that meet this requirement. Okay. One thing that small thing that we want to fix here is we want to replace this no column name that looks ugly to something more meaningful. Okay. So we can do this by using column alias, which is to add AS, keyword AS, followed by the desired column name, such as num-graded, after the keyword S. Okay, so now it shows the column name as num-graded for these numbers. Okay, so similarly, we can add the average, minimum, and maximum assignment score for each student, like this. Okay, AVG assignment score. Okay, so when the one line becomes too long, it's a good idea to change lines like this. Okay, count star as num-graded, average assignment score as AVG score, for example. Okay. Then the minimum mean assignment score as lowest, max assignment score as highest, okay, from student and assignment tables. Okay, and don't forget the comma here. And also it's a good idea to keep some consistency between the naming conventions, such as capitalizing the first letter. Okay, and also fix those typos and syntactical errors. Okay, so now we have more full-fledged statistics for each student, including their average, lowest, and highest scores. Okay, so let me lowercase the c. Okay, so if you think some of these average scores has too many digits after decimal, we can round those numbers. Okay, so what I mean is we can add a round function outside the average. Okay, round the number returned from the averaging aggregate functions and only keep two digits after decimal, okay, to make it look better. Okay, so now we have a list of students and their assignment statistics. Okay, we are almost done for this problem. Okay, the only thing we have not addressed yet is we only want to show those students whose average score is higher than 80. Okay, so this last condition could not be addressed by the where clause because the average of the assignment score was not in the original datasets, but instead they come from the aggregate function from group by. Okay, so that means we have to use the having clause instead of where to translate it. Okay, so the last thing we need to write is here, having this AVG assignment score. Okay, having AVG assignment score is greater than 80. Okay, so basically we just want to keep this record and these three records because their averages are higher than 80. Okay, and now the results only contains 4 students whose average score are higher than 80. Okay, so as you can see, this is a SQL query involving group by that could become pretty long, but using this strategy, we can easily generate the SQL query to meet the requirement. Okay, so that's the first example. Hope it helps you to understand the usage of this SQL strategy involving group by to come up with a SQL query to meet the requirement. Okay, so as a second example, okay, let me do it again. The second example is here. Okay, we want to show this thing. Okay, so that's all students and their number of late or missing submissions. Okay, so the expected results are again a list of students and a list of numbers representing the total number of submissions that they made. Okay, that are either late or missing. Okay, so we don't want to count normal submissions that was submitted on time. Okay, we want to aggregate for each student, okay, their number of late or missing submissions. Okay, so this is the final SQL query needed, but let's try to come up with this SQL query using the strategy. So the first step is select everything from all relevant tables. Select star from, okay, so in this case, of course, we need student table again because we need their names. Of course, we also need assignment table because we have to use it to check which assignment submission is late or missing. Okay, so select star from both student table and assignment table. Okay, and the second step is to work on joining these two tables using their primary key and foreign key relationship. Okay, so this is the same with the previous problem, where student.studentID, okay, representing the student ID column in the student table, equals to assignment table's student ID column. Okay, and run the partial results. Okay, so we have done first two steps, which are like boilerplates to almost all problems. Okay, the next step is to narrow down the rows by applying appropriate conditions using the where clause. Okay, because the current partial results is far from our expectation. Okay, we want to count the number of late or missing submissions. Okay, so let's take a look at the current results here. Let's take a look at the current partial results here to get some insights. Okay, so let's take a look at the first row. Okay, so this submission was submitted before due date, okay, because it's February 10th, but the due date is the next day. Okay, and it also received an assignment score. It also received an assignment score. Okay, so obviously the first row doesn't count as either late or missing submissions. Okay, so the same thing happens to the next three records here. Let's take a look at the fifth records in total. Okay, so this will count as missing submission because the submission time for row number 5 is null. Okay, it has never been submitted by this student. Okay, so this will count. What about row number 6? Okay, it is not graded, but it is submitted. It is submitted by Ellen White on February 12th, while its due date is February 11th. Okay, so this counts as a late submission. Okay, so to sum up, we want to count the total number of submissions like these, okay, either missing or late, by comparing the due date and submission time. Okay, but we don't want to keep submission records like the first 4, okay, which are just regular on-time submissions. Okay, so to translate this logic, the where clause we need is where either submission time is null. Okay, submission time is null represents missing submissions, or submission time is greater than due date. Okay, because if submission time is greater than the due date, it means it's a late submission. and we cannot have two where clauses, so we use AND keyword to combine them. And also don't forget to put a set of brackets to logically wrap up these OR conditions between the two expressions. Okay, so run the query again, and now we have a much fewer results, only 17 rows that are either the submissions that were done after the due dates, okay, like these, okay, or those submissions, assignment submissions, were never done, okay, where submission time is null. Okay, so this completes step number 3. Okay, narrow down the rows by applying appropriate conditions using where. So the next step is identify column or columns to group by and select that column. Okay, so remember, our expectation or expected final result will be a list of students and their number of late or missing submissions. Okay, so that means the columns based on which we group by should be the first name and last name of these students. Okay, so remember, whatever you group by, copy it and use it to replace the star or asterisk right after the select keyword, okay, to avoid errors. But this error, another error that I had here is I think I used wrong. I should have used comma here. Okay. Okay. Now I have a list of students. Okay. So the next step. Okay, the next step is to expand the selection by adding aggregate functions. Okay, because we do not only want the list of student names, but we want a list of numbers representing the late or missing submissions. Okay, so that means the aggregate functions we should use is count star. Okay, we count star because we have already used this filter to keep only late submissions or missing submissions. Okay, so now we got the list of late or missing submissions for each student. Okay, and don't forget to use the column aliasing to give it a meaningful name. Late or missing, for example. Okay, so that will complete step number 5. Expand the selection by adding aggregate functions. The last step is to narrow down the rows by applying appropriate conditions using having. Okay, having instead of the where clause. Okay, so in this case, actually we don't have any need to use having clause because we have already meet this requirement. Okay, but in case the requirement was something like this, show all students and their number of late submissions only for those where this number is greater than 1. Okay, so for example, we want to excuse Gary Yellow from this assignment submission alert because it's only one time that this student made this mistake. Okay, so we want to tease this record out. Okay? So in order to do so, we can use the having clause to set this filter where count star is greater than 1, okay, so that I can tease out the last result from these intermediate results. Okay, and finally, we got these same results as we have seen before. All right, so that's the 2 examples I used to demonstrate the usage of SQL strategy to easily come up with the select statement involving group by. So hope this video helped. Thanks for watching.